Utilitizens, back with me again, Aji Gautama Putrada. I am your lecturer for Parallel and Distributed Systems. This is meeting 11 about shared memory model or FRET. In our sixth video, we will discuss about consumer-producer problem. So if before we had the race condition, consumer-producer problem is a similar but more specific problem um, than race condition. So in producer and consumer problem, we have two threads. Thread 1 is called producer, so this is thread 1, and thread 2 is called consumer. This is thread 2. So basically this is also multi-threading, and we have a buffer, and just like the name, the producer fills the buffer. So the producer fills the buffer, and the consumer takes what's inside the buffer. And what is the problem? The problem is, what if the buffer is still empty, and then the consumer consumes, and that will result in a crash. Also, when the producer fills the buffer and then the consumer consumes the buffer until it is empty, it will also crash. So what we need to do, crash. So what we need to do is we need to block the consumer when the buffer is empty. Block when buffer is empty. So how do we do that? We have that technology called lock, acquire, and release. So lock, acquire, and release, can it be used in the consumer-producer problem? The answer is no. And why? Why? Because uh, lock, acquire doesn't block the its own thread, it blocks other threads. So lock acquire blocks other threads, and this is not what we need. What we need is a synchronization process that can we need what needed is we need a synchronization process that can block itself. So here the consumer needs to block itself, not blocking other threads. So we cannot use lock, acquire, and release. Now what we know that can block itself is sleep. We have learned about time sleep, and sleep blocks the thread itself, and then it unblocks the, its own thread. Can we use that? So can we use sleep? And the answer is no. Also no. Why? So it blocks itself, which is needed. So this is good. But what it shouldn't do is it also unblocks itself. And this is not what we need. What we need is what we need. What we need is another process, another thread unblocks us. So this is just the opposite of what we need from lock acquire. Lock acquire blocks other processes, but is unblocked by other processes. Here, we need something that blocks itself, but is unblocked by other process. And the answer of what we need is something called condition wait and notify, and we will learn about condition wait and notify in the next video. Thank you for your attention. I'll meet you in the next